Now, let's finish this section by looking at the end behavior of some special functions. Let's start with the exponential function e to the x. As x approaches infinity, e to the x approaches infinity. And as x approaches negative infinity, e to the x approaches 0. The graph approaches the x-axis from above, so the horizontal asymptote is y equals 0. Now, let's take a look at the natural log function. As x approaches infinity, natural log of x approaches infinity. As x approaches 0 from the right, natural log of x approaches negative infinity. The graph has a vertical asymptote at x equals 0, and it only exists for positive x. Now, let's talk about trigonometric functions. Trigonometric functions are periodic. That means they repeat their values over and over. For example, sine function oscillates between 1 and -1. That means it keeps going up and down between 1 and -1, and it does not approach a single value. So, as x approaches positive and negative infinity, sine of x does not have a limit. The tangent function behaves differently. It has infinitely many vertical asymptotes, and it does not approach a finite value. Now, let's look at example 7. We're given f of x equals 2 plus 3 times e to the x over 7 minus 5 times e to the x. And we want to find the limit as x approaches infinity, the limit as x approaches negative infinity, and describe the end behavior of the function. Let's start with the limit as x approaches infinity. As x approaches infinity, e to the x approaches infinity. So the numerator approaches infinity, and the denominator also approaches infinity. So this is an infinity over infinity type. When working with exponential expressions, divide everything by the biggest exponential part in the denominator. In this case, that is e to the x. So we divide the numerator by e to the x and the denominator by e to the x. Next, we need to rewrite this. For the numerator, we have 2 over e to the x plus 3e to the x over e to the x. For the denominator, we have 7 over e to the x minus 5e to the x over e to the x. Now, let's simplify each expression. Two over e to the x stays the same. 3e to the x over e to the x is 3. 7 over e to the x stays the same. 5e to the x over e to the x is 5. As x approaches infinity, 2 over e to the x approaches 0, and 7 over e to the x approaches 0. So this becomes 0 plus 3 over 0 minus 5, which is negative 3 over 5. So the limit of f of x as x approaches infinity is negative 3 over 5. Next, we are going to find the limit as x approaches negative infinity. Now, let's go back to look at the end behavior of e to the x. As x approaches negative infinity, e to the x approaches 0. So, as x approaches negative infinity, e to the x approaches 0. And 0 times 3 is 0. And as x approaches negative infinity, 5e to the x approaches 0. So this becomes 2 plus 0 over 7 minus 0, which is 2 over 7. So the limit of f of x as x approaches negative infinity is 2 over 7. Next, let's describe the end behavior of the function. As x approaches infinity, the function approaches negative 3 over 5. And as x approaches negative infinity, the function approaches 2 over 7. So this function has two horizontal asymptotes. On the right, y equals negative 3 over 5. On the left, y equals 2 over 7.